Welcome to the lecture series on object oriented analysis and design. In the last two lectures, we have been looking at unified modeling language, how it happened. It did not happen out of blue, it did not happen in vacuum. It is very nicely developed, well supported by major industries. This idea was very nice in the US when something that got so many industries automatically latching on to it was deemed something which is practical. It is now no more classifiable as academic research or industry. If half a dozen industries are good industries like what UML had, the trend is different in the West, US or the West. The trend is like that. If a good 6 or 7 major industries are supporting an idea or something, it is automatically understood that the classification vanishes. That is how the system is built. Unless all the three wings come together, it does not happen. That is all. It is a thumb rule. We believe that if more than 2-3 good industries or good organizations are together, the blending of those ideas is always there. So, we need to understand that technology thrives on such things, and that is where we grow further, we address more complexity. What we ended up here towards the end of the last session is the fact that UML can have variants. There is no reason to believe that this exactly is UML that goes by the object management group's notation guide, semantics, object constraint, 3 major documents. Variants are there, and till today we do not agree that rational rows is the best fit for all this. Rational rows is a product, it is a case tool, it talks UML, the UML that is good enough for what we normally do and talk to all others. However, it is rational rows UML. There is no second opinion, it is a tool, it is not even rational rows UML, it is a tool, object oriented analysis and design tool that conforms to lot of things which are standardized by object management group as UML. UML extension for object tree, UML extension for business modeling. Now, all these things are also possible. We said that we do not have to wait for somebody to define, we can create our own extensions, user defined UML extensions. By saying so, once again I wish to underscore the fact that it so happened that object oriented analysis and design became synonymous with UML and vice versa ever after 2002, and the presence of tools, strong presence of tools has been another reason why the fueling of this exercise went on. We have had so many people commenting that, well, it is taking us this far, but it is not enough. We still are not able to ground what we are claiming. We are still worried about the idea of deployment, many things. There are so many other things for various reasons. We are not going into that. It has its flip side. As I said in the earlier slides, UML does certain things, UML does not do certain things, but all the things we were attempting to do. For toy projects, for less than a lakh of code, you can always argue that everything is happening. We are talking about a granularity, a complexity of a project where those small things which we wish UML was helping us and is not helping mean lot, mean millions, mean lot of man hours. That is how we are talking about. So, the UML semantics document is primarily used by tool vendors. It is easy, it is a quick check. The tool fellow tells we have done this, this is a quick check. Includes the following inside view information for a given UML package, general introduction, concept definitions, relationships and constraints expressed using UML's graphical notation and English prose. Well formatness rules, rules and constraints. Object constraint language enables us to tell these are the rules and regulations which will go over and above or in tandem with, whichever way you want to look at different expressions, but then they should be considered alongside the mathematical associations, aggregations and generalizations. In other words, even if mathematics is not making this rule happen, As we progress, this rule can be implemented, you can force it to happen. And standard elements also contains appendices on the standard elements, and the UML glossary gives a nice documentation, notation guide, semantics, notation, presentation, style guidelines. Stylistics are very important. If you look at it, when we started documenting seriously, we means not the manufacturers of the tools, but all of us, whoever is using the tool, whoever wanted to get into anything to do with computer related documentation, the Chicago style guide was very necessary. People who write research papers, they use APA, American Psychological Association style guide. What does the style guide tell? It tells that if the document is written like this, people assimilate it faster. Whether we like it or not, the APA style guideline is still dominant. If you want to cite, this is the style. The citation of a paper should be like this. Everybody is familiar with this, everybody understands similarly. There are other guidelines. Chicago style manual was very famous for quite some time, until we ran into the Microsoft style guide. Microsoft style guide became absolutely synonymous with what we do, because we use Microsoft Office, we use Microsoft tools. It translates. What you are doing is simply translating into the documentation. Nothing, no commentary outside of the fact that it is like this. We use Microsoft Office, we use Microsoft tools, and it is happening. We were hoping someday that Google will also come up with a style guide with all the things that Google do, but fortunately or unfortunately we do not need it, because most of the things are relatable now. They are not so new to the people who are using it. Semantics, notation, style guide, provide notation samples. Again, notation is something which is very specific in scope. It is not something where anyone who sees this notation will concur immediately that this is the way it is. It needs lot of understanding, it needs lot of study, and then we say it is like that. The UML extension documents provide user defined extensions, extended the UML to object tree, business modeling. Business modeling remains a big question mark. We had what is called, outside of the software development process, what is a business process and how does it impact the software development process. Now, the business dynamics are such that it becomes very difficult. We are not able to do crystal ball gazing, we are not able to find out how the markets will change. So, therefore, the business modeling was not so easy, and we got settled to what is called the business logic for some time, hoping that it is a model, but then that is the engine, that is a driver, and we are not too sure how that fits into many contexts. A UML extension is a set of extensions. So, once again after all this we went back very quickly to data encapsulation. It is not necessary to know what is happening as long as the contract is obvious. Please recall, in earlier lectures we talked about what Bertrand Meyer has proposed, that is design by contract. We do things as per the contractual obligation or contractual understanding. What is happening within the stakeholders is of no serious concern to us, or put it other way, we are already saddled with so much of complexity. This is not necessary, because neither I am going to impact that kind of a deep business of the stakeholder, nor the stakeholder is wanting me to understand all that deep business impact. So, we said this is contract based, design by contract. A UML extension is a set of extensions that extend, customize or tailor the UML for a specific domain or process. It is not simply necessary. As I said, we have gotten accustomed to working with black boxes, to working with blocks, where it is enough for me to proceed further with the precondition and post condition, and if I can derive the post condition, if I can derive from the post condition what was the precondition, it is correct, we do not have to go through. So, it is a nice way. We have learnt all these lessons through structured programming 2-3 decades, wonderful pioneering ideas happened, so many people worked on it. Otherwise, we cannot escape, even today we cannot escape that we will be very easily pushed into what was called the art of programming. There is no second opinion till today, and if we have to thrive on making it a science, we have to do further, but there is no excuse on that. You come up with an idea your own way, you cite a problem in your own way. How to relate it to what others might have experienced and might have solved, there lies the idea of talking science. That is when we say that all people would have faced this. It specializes the UML, but does not change the UML terms or redefine their meanings. The object constraint language is a formal, easily readable and writable non-programming implementation independent language that is necessary. Implementation independent language. The more generic we become at every level, the better it is for taking things more and more towards science, and that also means we are taking more and more away from what we started with on hand, a challenge, a problem, a task, whatever it is used for expressing type pure side effect free constraints and expressions, is used for attaching constraints and other expressions to the UML models and modeling elements, is used to specify the well formedness rules of the UML within the UML semantics document. All these are known. The principles of modeling, the choice of what models to create, has a profound influence on how a problem is attacked and how a solution is shaped. It is very, very natural for human thinking that we gotten into one outlook, one view, one assimilated way of proceeding. For quite some time we are virtually blindfolded on what we threw out in arriving at this. It is very natural way of thinking. We have thrown out a few things, we have gotten lot of things, lot of views are there, functional, non-functional, organizational, everything came. The next step happened as what we called the distilled wisdom or otherwise of the team or people who are looking at it. We arrived at this. In the process we threw away a lot of things. Who will keep track of it? If there is a model, you are very likely to encounter at this point in time you are progressing like this you have thrown out, probably it can come back, something will prompt, something will tell. Imagine, it is so nice that at that time you threw it out, now it may come in handy. The best models are connected to reality, that is the simple idea that we have been talking about. No single model is sufficient, every non-trivial system is best approached through a small set of nearly independent models. For everything you need multiple models. This is another nice word which we have been using in the context of design. Outside of those optimization, the typical ideas of design, what is so specific to object oriented design is the model. Analysis is object identification, which is very difficult. Design is object identification plus model. That is the model, and we have normally a few independent models which we have to harmonize, we have to put them together. There are so many things in UML, structural things, behavioral things, grouping things, annotational things. Which dominates? It depends. It depends. So, we think that a small team is always much better than an individual, because it is punctuated by the choices made by the individual in many of these cases, and how much ever the tool is sophisticated, how much ever the complexity which an individual can handle has now increased. We want people to work as teams, put together as teams. Now the teams can run through because there is a seamless integration, otherwise the team phase, they are so distinct, there cannot be too much of an overlap outside of the interface elements. We do not want too much of an overlap. Structural things, behavioral things, grouping things, annotational things. The structural things are very technical: class, interface, collaboration, use case, active class, components, nodes. Nothing is new for us. Those of you who have already gone through the earlier set of lectures, everything is known. It is just that UML said this is how you will have to use this 7 kinds of structural things. class, interface, collaboration, use case, active class, component and node, that is all 7 things, structural things. Behavioral things, interaction, state, again it is known. How do they interact? What is the way in which the messages get exchanged among a set of objects within a particular context to accomplish a specific purpose? Again this idea of context is something which we wanted to be away from. In the earlier days, the more context free, the better we are in taking things to the machine. Now thanks to all these paradigm shifts and the tools, we are now able to factor good measure of the context. A state mechanism is a behavior that specifies the sequences of states an object or an interaction goes through during its lifetime in response to events together with its response to those events. Grouping things, packages. So, earlier on in one of the lectures I was mentioning that libraries are there. Well, for quite some time multi-paradigm, multi-language work was not allowed at all. It was considered a serious indiscipline. If you are talking about this language, you have to work only through this language. The discipline is not meant for making things harder and harder for the fellow who is solving the problem first time, but people who have to use the solution over and over again will immensely benefit if the fellow follows those nice standards. So, no multi-programming, no multiple language programming and no way of talking about multiple paradigm programming. Things have advanced. While we do not say object oriented paradigm has been so well established that I do not have to look for other paradigms for even terminology. It is there, it is explanatory, self contained. The paradigm is a very well established paradigm with fantastic documentation and clarity of purpose and work. Whereas, we have been talking about the other ideas where making a package. How do I make a package? That is the question. What is a package? Is the set of library routines for mathematical functions a comprehensive and a complete package, or should I take it out, break it into smaller packages, scientific computation, numerical methods, other mathematical functions? What is the way in which we should do? Should all the library functions be put together with only one header, or is there any other way? So, the idea of package was there for quite some time. I myself have used it in my MTech, that is way back in 86-87 on Omnix. Omega 58000 was the machine. We had rich Fortran libraries and the entire Central University was depending on the Fortran libraries, and we were getting the problems. We were in a school of mathematics and information sciences. So, we had good component of mathematics when we were solving the problems using machines, using computers. So, we also felt that if we can access those functions which are mathematical functions which everybody uses, we will do better programming, we will talk about better complexity, hope we will do that. So, we got our Omega people give us that extension, a switch F77 Fortran 77 libraries which were very polished, fantastic mathematical functions were there. So, using the C programming language, I can use in the command line a switch minus F77 and I can link to this particular package called mathematical package, mathematical libraries. And we were claiming that we were able to put lot of maths in what we were talking, and it was becoming very difficult to classify our exercises whether it is a mathematics problem or computers problem. For quite some time, for the initial 3 semesters, good amount of time had most of our work had mathematical component in that, math packages. Annotational things are the explanatory parts of UML models. Now, what is happening in the field of, this is just about a completion of UML, all 4 things. Today, if we talk about packages, even though Ada was the first language that wanted to implement packages in a very big way, and C++ tried, but then it got bogged down with inheritance, componentization and reuse. The idea of package, which is like this, what I described, found maximum implementation in Java. Everything is a package in Java. Talk about everything you want to do, Java has a package. It's open language, and for quite some time it was called legacy, and now it is coming back. It's coming back, and for several years we have been thinking that the idea of package is so fantastic that for all the mobile applications Java may be the best suited language. It was almost commonsensical, because whatever you want to do with this instrument, the instrument need not be so sophisticated, but it can connect to the package. Any language that allows us to connect to packages is best. So, we thought that Java is an automatic choice for mobile application development. These days they are changing over. Google, they are talking about Kotlin. Kotlin is a new technology. It was good working with Java and then trying to migrate languages. Language design is a good study in itself. It is nice to talk about anything that is abstract, because it quickly connects you to so many people who started with a similar problem, but made giant leaps. You may also do that. Every great achievement starts with a small step. Had a problem on hand, you are trying to look out for somebody or something that has been done in this area which is before what you experienced, and in the process it may open a great door. That is the power of abstraction which we should think of. So, relationships in the UML: dependency, association, generalization, realization. Dependency, association, generalization, we all know these dependencies are something which we talked about as a semantic relationship between two things, in which a change to one thing may affect the semantics of the other thing. Association is very clear, the mapping is very clear. What we are talking about is a change. This is necessary because what punctuates software engineering is its enormous flexibility and capacity to make change happen. That is a core strength for anything and everything. The core strength will also be the core weakness. There are no two opinions about. So, how do we judge the change impact? We do not have the luxury to say no to the change. How do we assess the change impact? What is a change impact analysis? Some changes cost more, some changes take more time, some changes will cost more and take more time, some changes can be done gratis, some changes simply cannot be incorporated. Software is the only discipline that gives you 4 options before saying no. You can explore as many as 4 options before saying no to change. It is the only discipline that allows you to do that, and we do not have a luxury to say no, because we started selling the idea of software engineering saying that please do not worry, you do not have to give me the total thing that you want to do. As we progress, we will build the total thing that you want to do. There is no reason to think that everything should fall in place straight, cast in stone and sent, and then we will do from that beginning. It is a nice discipline, it is a nice intellectual challenge. It has been proving to be so for the last 60 years, and it will remain so. We still have plenty to do. So, a dependency is a semantic relationship between two things in which a change to one thing may affect the semantics of the other thing. So, we have been building dependency software while our goal was to make dependable software. They are two different things. The goal is correct, the software must be dependable, but then it does not mean that there will be too many dependencies. How to manage it, that is a challenge. A realization is a semantic relationship between classifiers, where one classifier specifies a contract that another classifier guarantees to carry out. So, we have realization which is a reflection of what Bettenmeyer said, design by contract. However, Bettenmeyer explained this idea amongst many other things. It is a very good fat book, Object Oriented Software Construction. First time we were talking about the idea called construction, and it happens in that manner. A realization is a semantic relationship between classifiers, where one classifier specifies a contract that another classifier guarantees to carry out. So, we saw the full concept behind what Bettenmeyer was calling object oriented software construction, an award winning language design called Eiffel. It is an award winner. it illustrated the primary concept that remained the most generalizable takeaway for everybody working is design by contract. It can be implemented using different notations, it can be implemented in some other manner, but the simple idea design by contract was very impactful. Outside of your constraints, outside of your rules, outside of your associations, you can simply tell that this is the contract, and as long as the contract is satisfied, no concerns, it is done. A diagram is the graph, it is very good, because whatever technology we talk, take for example in cloud computing, whatever technology we talk, the impact is seen in what is called service level agreement. The metric, the single biggest metric based on which we can judge the efficacy of something that is being claimed happening in cloud computing is a service level agreement. So, we have talked about design by contract, which is more technically verifiable, more dense, and fits well into the gamut of things that we are talking about. UML has this many diagrams, of which these are 1, 2, 3, 4 are structural diagrams. The structural things are nicely seen, they dominate the 1, 2, 3, 4 diagrams. The behavioral things dominate 5, 6, 7, 8, 9. So, that is how we are talking about, and this is how it is. Structural things, behavioral things are not many, structural things are not many. So, equipped with 7 structural things, 2 behavioral things, 1 grouping thing, 1 annotational thing, you are addressing a phenomenal complexity, and it is just 9 diagrams in the earlier lecture. And if you adhere to this, you are likely to see object oriented happiness very frequently. Use case diagrams, actors, use case, this is how it looks. What does a resource manager do at the topmost level? He manages resources or she manages resources. What does a project manager do? Manages projects. What does a system administrator do? System administration. It is a top level diagram. So, it reminds the early days of saying that explain the functioning of a transistor radio. So, it is easy to draw one block transmitter, another block receiver, put one lightning between these two, this is the functioning of transistor radio. If it is 1 mark question, it is all right. If it is 10 mark questions, not at all adequate. So, this is a very high level use case diagram which is useful. However, this should be expanded further. A resource manager can do this many things, managing resources. Class diagrams, we have seen lot of class diagrams, lot of methods, lot of models. This is an example of a UML class diagram. So, in summary, with 7 structural things, 2 behavioral things, 1 annotational thing, and 1 another package, we are able to address a range of complexity using the same technology idea called object oriented paradigm, which has been baffling many intellectuals for 10 years, for 10 long years between 1990 to 2000 and 2002 when UML 2.0 happened. With this simplicity, 9 diagrams and only these simple things to know, we were able to address all the challenges except that component or aggregation, which became CMG and later on ICMG. So, these are all well known example of sequence diagram, and for the sake of completion, I will go through the state chart. They have all been discussed, they are all very much part of the earlier methods. We do not have to talk about more. Activity diagram, same problems, packages and components. We were not able to do much on components, but using UML we were able to do packages. That is the plus of UML. Components, they were becoming very subdued. So, component diagram, deployment diagram, what we have done is OOAD using UML. Thank you. The end of this lecture. We will meet again in the next lecture.